All right, section 10.5. We actually used this word before, but this word really doesn't, I don't believe it has anything to do with how we used it before. Remember sine, cosine, tangent? Well, we're going to actually talk, let's do this. We're going to talk about the tangent. But it's not the same kind of tangent that we talked about when we did sine, cosine, tangent. So let's just write that down. This is tangent. Do you remember when we did sine, cosine, tangent? I don't know. I might have mentioned in this class or the other class that that I don't know where those words came from. I never looked it up before. Well, I looked it up the other day. It was actually yesterday because my CP class I'm teaching them that kind of stuff. So I looked it up, and it's kind of what I thought it was. I figured it was Latin for something, and it was. It was like Latin, which means like to touch. All right. So you think. Tangent. How in the world is tangent opposite over adjacent? How does that have anything to do with to touch something? Well, glad you asked that question because I'll show you. Let's copy that. And always takes a second the first time I copy something when I open up this program. Alright, so here's a circle. And let me just show you what a tangent to the circle is. You ever hear anybody, and I do this quite a bit, I'm pretty famous, actually, in my classes anyway, for doing this. I'll start talking about something and then go somewhere completely unrelated. You ever notice that? Yeah. I've been doing that for years, and I try to stay on topic, but sometimes, you know, I just go off, and I don't care. Every once in a while, I just think it's a little more interesting than just staying on topic. But anyway, have you ever heard anybody use the expression, oh, he's gone off on a tangent, or that conversation went off on a tangent? You ever hear anybody say that before? Well, the reason, you never heard that? Well, listen for it, because you may hear it now. Now that you know what a tangent is, well, you will in a second, hopefully. Now you know what a tangent's going to be. You might hear somebody say this, whether it's on TV or somebody in conversation or something like that. Now, kids usually wouldn't say that, but if you hear an adult, they'll say, oh boy, here he goes off on a tangent again. And that's what I do a lot of times. And what a tangent is, remember, in Latin it means to touch. So what it is, it's a line and a circle, but it's not like this because that goes through the circle. That doesn't touch the circle at all. So where do you think the tangent's going to be? It's just going to hit, boom, right there. All right, and it just touches the circle just in one place, okay, at one point. So a tangent technically is a line. It could be a line segment as well, but we define it to be a line that just touches the circle or hits the circle or intersects the circle, I guess, at one point. Not at 2 points, just at 1 point. Because if it hit at 2 points, what would it do? It would go through the circle. That's right, it would go through the circle. Travis?
So can it still go inside the circle, but stop before it gets to the other side?
No, because we define it to be a line. So if I did that, you say, well, that just hits the circle at 1 point. But technically, a tangent is a line. So where is that line going to go? It's going to keep on going, isn't it? So let's do this. So watch, this thing could keep on going like that, and eventually it would hit the line at 2 points, wouldn't it? So it doesn't just go like this and stop. So it actually is a line. I guess that's why they define it to be a line. It's a line that intersects a circle just at, I don't even know if they use the word intersect. Let's see what it says. It says, is a line in the same plane as a circle that intersects. Yeah, they do use that word. Intersects a circle at exactly 1 point. All right, so we are talking about it's in the same plane, but that's kind of an assumption, I guess, if you want to think of it. So that's a tangent line. That's it. See what it means by going off on a tangent, right? You were supposed to stay right here on topic, but what happened? Whew, they go way off topic. Like this circle is your topic, okay? And so you want to stay on the topic, but what happens with my conversations half the time? They just keep on going. My mind just wanders, and I just say things, and there we go. But you probably don't mind that too much anyway, do you? Probably. All right. Okay, well, that's a tangent. That's the definition of a tangent. Let's let's talk about this point. See this point right here where it actually hits the circle? We call that the point of tangency. We'll refer to that every once in a while. All right, so just want to write that down because I will talk about that. That point's going to be pretty important in a couple different situations that we have here. All right, so that's our point of tangency. It's where that line hits that tangent. So if I call that line L, circle A, we would say that line L is tangent to circle A at this point. We'll call it B, at point B. Everybody see that? So the line is tangent to the circle at that point of tangency. We good? All right, pretty easy. Now, how many tangents are there to this particular circle? As many as what? Give me a number. How many times could I do this? As many times as I want. An infinite number of times. That's what I'm looking for, okay? Infinite actually is a number, all right? It's kind of a weird number because you don't actually stop at infinity, right? You can't get to infinity. You keep on going. So you're like, well, how can that be a number? Well, infinity is actually a number. It's kind of weird. I don't understand all that myself, but look, I could keep doing this all day, right? And all week, and all year, and there would be no point to it at all. Just showing you that you could keep doing this over and over and over again as many times as you want. And some people say, well, look, you eventually fill up the circle if you do that enough times, because here's a point here, there's a point right next to it that touches it. But really, 2 points, you can get, this is kind of weird too, but you could take a point here and a point here and get as close as you possibly can, and they'll never ever touch. You can always get closer and closer and closer and closer and closer, and they'll never actually touch each other because a point doesn't have any width. It's not like we do this little dot to represent where a point's located, but it's not really a point itself. So you could get 2 points that get infinitely close to each other. When they actually are on the same point, then they're not 2 different points anymore. They're actually the same point. Does that make any sense? Okay, so really you can't get 2 points that touch each other unless they're actually the same exact point. All right? So don't worry about that too much. Again, what did I do? I went off on a what? Tangent. Okay, there you go. So at least you'll remember that. So you tell me sometime, right? If you go home and you hear somebody in conversation or you hear it on TV or something like that about somebody going off on a tangent, let me know because I bet you'll hear it somewhere. All right, let's do another one. I think I copied that circle already. Yep. I'm going to put 2 circles down here. This is just a couple definitions. This is not really super important, but let's put that right there, and let's put that about right there. Actually, let's make these smaller. It'd be a little easier if I made them a little bit smaller. Okay, that's good. They could be equal. They could be congruent circles if we wanted to, but I'm not going to. Just keep it like this. Let's use this nice blue. All right, here we go. We could have a tangent that hits both of the circles. Let's try my best. And I might have to rotate this thing around a little bit. It's not going to be that easy. Let's try it again. Which, about right there. Oops. Oh, what am I doing? Why is my line not drawing? Uh-oh. There we go. What was going on there? I don't know. Alright, let's do this. About right there. Oh, that's pretty close. Just pretend it hits that circle right there. It looks like there might be a little gap in between, but let's just pretend. So it hits right here, and it hits right here. So look, this tangent is tangent to 2 different circles, isn't it? It hits this circle just at one point. It hits this circle at just one point. So we say they're tangent to both circles. We just call this a common tangent. Just definitions right now. So that's a common tangent because it's in common with both of these circles. It's tangent to both of the circles. How many common tangents can I have on 2 circles? I can have 2 of them. I could have another one too, couldn't I? If I could draw it. I got lucky on this one. Let's see. It would be about right there. Oh, that's not too bad. It is better than the first one. It's not as easy as you think. Alright, so watch. It hits that circle right here, and it hits this circle right here. So look, I've got 2. Can I draw another line? Well, actually, I could. There's more than just 2, isn't there? By the way, they call these common interior tangents, I think. Let me see. I don't even see where they say it. I've seen it somewhere. Yeah, they're common interior tangents. Okay, then you can have a couple other tangents. Where would another tangent be drawn?
Could you draw a line just straight, like connecting?
Straight? They're all straight, but a line connecting them? What do you mean, connecting them?
In the middle of them.
Yeah, that wouldn't be a tangent. Like from here to here?
Yeah, but it's from the outside to the outside.
From this outside to
No,
this
the
outside?
first outside.
From this one to this one?
Yeah.
Yeah, but it's a line. It would have to keep on going, so eventually it would go through the circle. And that wouldn't be tangent. Okay, it can only hit the circle at one point on the circle. Right there and right there. See that? So your question was, could I just go from like here to here, right? Is that a tangent? Is that tangent to both of the circles? Well, it only hits a circle here at one place, doesn't it? It only hits a circle here at one, but the definition of a tangent is what? It's a line, right? Even though I didn't put arrows on all of these are lines, so that line would eventually come out here and hit the circle in two places, so that would not be a tangent. Whoops. Let's get rid of some of this stuff. Does that make sense? Good question, though. Alright, we got another tangent. What color haven't I used yet? Green. Alright. So let's try about like this. Oops. Oh, that's what I could have done. I didn't have to rotate. I could have just done that. Alright, so there we go. So there's your 4 tangents. So we have 4 common tangents. We have 2 interior tangents and 2 exterior tangents. That's basically just that's just vocab anyway. Thank you. That's just vocab. We're really not going to do a whole lot of stuff with this. Kind of. We are a little bit. Don't worry about it. Yeah, I'll talk about it when we get to it. Alright, enough of that. You could have a circle that's tangent to a circle. So how in the world would you have that? A circle tangent to another circle. Let's make it small. What do you think? If the circles are tangent to each other, how do you think they hit each other? Do you think one's inside like this? Is that tangent to another? No. What would that be? We talked about that. Well, right here, just this right here, this situation. What would I call this? Yeah, we didn't call it bullseye. No, it's not inscribed. We only talked about it one day. Anybody remember? We did talk about a bullseye. Starts with a C. C-O-N. Concentric. Nobody remembers that? Yeah, I thought you knew that. All right. Concentric circles. Okay, so it's not concentric. So if they're tangent to each other, remember, what does tangent mean? It just hits at what? At one place. So would that be tangent? No, because it hits at 2. All right. If it was tangent, what would I have to do to this? It would barely hit, right? It would just hit at, boom. It just kind of glances off of it, doesn't it? So that right there, see that point right there? Okay, so those 2 circles would be tangent to each other. There's another way I could make them tangent to each other. I could take this, put it inside here, and do what? Let's just put it up here just for fun. I could put it so it hits right there. Those 2 circles are tangent to each other, aren't they? And we will do some stuff a little bit later when we talk about 2 circles being tangent to each other. All right? And there is a relationship and all that kind of stuff. All right, but that's just vocab right now. That's all I'm worried about. Well, I wouldn't say I'm worried about it, but you know what I mean. All right, let's do a theorem. We haven't done any theorems yet. We haven't said anything about these tangents and what they do and all that kind of good stuff. So what we've done so far doesn't really help us solve for anything. All right, but what we're going to do right here does. So watch this. If I have, let's go different color here. If I had a tangent to a circle, and let's say it's tangent right there. It doesn't have to be horizontal. I kind of made it look a little bit horizontal. It's a little bit slanted, but so this line right here is tangent to this circle. All right. What it says is this. Let me just read it. It says, in a plane, a line is tangent to a circle if and only if it's perpendicular to a radius drawn to the point of tangency. So watch. If I said that this was tangent to the circle, guess what would be true? It would be perpendicular to the radius. Okay, see that point of tangency that I drew already right there? I'll tell you what, let's just call that point A, and we'll call this circle B. So if I drew a radius from the center, of course, the radius has to start at the center, and if I go to that point of tangency, you can almost just guess what's true about the yellow line and the pink bicolor line or whatever. It's perpendicular. Okay, it doesn't just intersect it, and we can't say it bisects it because remember what a tangent is. A tangent's a line, isn't it? Okay, but what does it do? It hits at a right angle. If you don't believe me, let's do another one. Let's go blue. Do you believe me? You don't? Okay. Whoopsie daisy. Let's just draw another tangent, just kind of at a crazy angle like that. All right. And what are we doing? We're going from, actually, let's make this blue again. Sorry. Let's draw the point of tangency, which would be about right there, I would guess, wouldn't you? Okay. So what happens if we connect a line from where to where? From the center, right, to the, yeah, let's use the words correctly. From the center to, not just to the tangent, because that would be from the center to the tangent, to the point of tangency. Okay, to the point of tangency right there, where it actually hits the circle. Okay, so if I do that, then look, what's true about the angle that's formed here? It's a right angle, so it's perpendicular. Okay? Oh well. That's alright. Alright? Everybody with me on that one? Okay, so if I go from the center to the point of tangency, then it's going to be perpendicular. I could do that all day long if I wanted to. And this is probably going to help you too, because look, if I like drew from here to here, get a right triangle, got a radius, right? Got a length and all that good stuff. So we'll talk about that a little bit later. Alright, let's move on. Okay, I'm going to draw a tangent, and I'm going to draw it to the point of tangency. Now, technically a tangent is a line and it keeps on going, but I'm only talking about the portion of the tangent that goes from this point to the point of tangency. Everybody okay with that? Alright, so that is a tangent. And watch this. I'm going to draw a little line segment from the center to that point of tangency right there. And I'm going to connect. Remember what I said? We could probably make a triangle out of this. I'm going to connect from there to there. Alright, so let's put some numbers in here that they tell us. They tell us that this is 9. Now, when they say 9 right here, where do you think that 9 is? Do you think it's from here all the way to the center? No, it's just from this point to this point right here on the circle itself. Does that make sense? That's 8, and this is 15. And let's put some letters in here. K, J, L. K, J, L. And they tell you that JL is a radius. Alright, that's pretty easy to see. We could have figured that out ourselves, couldn't we? That JL is the radius. And it says determine whether KL is tangent to JL is tangent to circle J. Yep. So I don't know that this is a right angle right here. But guess what? I could figure out, with this information right here, I could figure out if this was a right angle. Now watch. If this was a right angle, then what would be true about KL to JL? They would be perpendicular, right? And it would be what? KL would be a what to the circle? A tangent to the circle. So the key is, I got to figure out, is this a right angle or not? How in the world would I figure out if that was a right angle? Okay, Pythagorean Theorem. Okay. So do I go 8 squared plus 15 squared equals 9 squared? No. What's this whole KJ? It's 9 plus what? You sure?
Oh, 9 plus 8.
9 plus 8. Why did you say 9 plus 8? It's the radius. That's right. From J to this point right here is the radius of the circle, isn't it? And I know the radius of the circle. The radius of the circle is 8, so that has to be 8. So what's the whole entire length? It's 17.
So
Now look. What's that?
If they equal each other when you do Pythagorean theorem, it's right.
Yeah, right. If I take a squared plus b squared and it equals c squared, then it's a right triangle. Exactly. Alright, so that's how I can figure out. Now look, they actually kind of made this easy for me. I don't even have to do Pythagorean Theorem, do I? Because look what I got. I got 8, what? 15, 17. Does that ring a bell at all? It's one of those Pythagorean triples. Remember that? 3, 4, 5, and what was it? 5, 12, 13. There's another one, 8, 15, 17. If you really wanted to, we're running out of time, but if you really wanted to, plug it into the Pythagorean Theorem. It will work, okay? 8 squared plus 15 squared does equal 17 squared. So guess what we have here? We have a right angle, which means if this is a right angle, what's true about KL to the circle? It must be, no, well, we know it's perpendicular because it's a right angle. It's tangent, right, to the circle. Okay, it's not perpendicular to the circle, it's tangent to the circle. Okay, so I can say without a doubt that KL is a tangent line to the circle. Make sense? Okay. Let's do one more. Now we're starting to get into some stuff where we're going to find the measurements and all that kind of stuff. Let's make this a little, oops. Let's try this again. Gotta hit the shift key, keep it in proportion. Alright. Watch this. I'm gonna draw a couple tangents. Let's go. I need some more colors. It seems like I run out of. Let's go orange. I haven't used orange. The red doesn't show up too well. It would be nice if it did. But watch what I'm going to do. I'm going to pick a point outside of the circle, right there. What I want to do is I want to draw two tangent lines to this circle from that point. So I start at the point, and I got to draw a tangent line to it. Now I'm going to actually stop at the point of tangency. Technically, a tangent is a line, isn't it? Keeps on going. But I'm going to make it a line segment. I'm going to start from this point outside the circle, and I'm going to draw a tangent to the circle. So I could go like that, but I want to take this to about, it would be about right there, wouldn't it? Would you agree that would be tangent to the circle at that point? Okay, and let's do tangent to the circle at this point. So watch, if I went like this, see there's the point of tangency, and so it would be about right there. That's pretty close. Not exact, but it's not too bad. Alright, so let's take a look at these two segments right here. If this was the point of tangency, and this is the point of tangency, if these two lines are tangents to the circle, look at the length of that, and then look at the length of that. What do you think? They're going to be exactly the same. That's right. They're going to be exactly the same. So if I call this x, what would I call this one? I'd call that x as well. Or if you wanted to, you could put a little tick mark here, a little tick mark here, couldn't you? All right. So that's going to be very helpful. So if you have a point outside the circle and you have two tangents drawn to the circle, the distance from this point, this outside point, to the point of tangency. See, I told you we'd be using that word quite a bit. So to that point of tangency, those two lengths, those two line segments right there are going to be exactly the same. Make sense? Travis?
Can they give you the angle of that and then ask you to find the arc?
They are going to do that stuff. We're going to do that in the next lesson, though. They are going to give you some angles in here. We're going to talk about the relationship between the angles and the arcs and all that good stuff. All right. I don't believe they cover that in this lesson. No, they don't. So I think that's in the next lesson or the one after that. I'm not really sure, but I think it might be the next one because that might be all the lessons. No, yeah. So I think it's the next lesson. We talk about the relationship between this angle and this arc and all that good stuff. All right. So we'll talk about the next lesson. Let's do an example like this. We got a few minutes here. Let's do an example just so you can see what they're going to do. Actually, I'll keep this all up here. The example is just really, really easy. I don't even know if I should have to go through the example, but I'm going to. Okay. Let's see. Yeah, none of these are really hard. Yeah, let's just do this. Let's say we know, they tell you in the information that this is tangent to the circle, okay? That this is the point of tangency and this is the point of tangency. And so this is way too easy. X plus 15, or yeah, it's 15, yeah, and 2x minus 5. All right, and they tell you this is the length of this segment, this is the length of this segment. So how would I solve for x, or how would I find the lengths of the segments? Yeah, just set them equal, okay? That's way too easy. We've been doing that all year, haven't we? So x plus 15, subtract an x from both sides, add a 5 to both sides, so x is 20. What if they ask you for the length of it, though? So what would this whole entire length be equal to? It'd be 35. Good. Okay, now this should be the same thing, shouldn't it? All right, so let's just put it in. 20 in for this. That's 40 minus 5 is 35. Yep, they're the same exact lengths. All right, so very simple, easy example on how to do that. We good with that? This is kind of introductory lesson. It's kind of like this whole circle chapter is kind of split in half. This is kind of like the beginning of the second half of the chapter is how I look at it, okay? Because the stuff from the second half kind of go together. The stuff from the first half of the chapter kind of go together. And this is kind of like the beginning of that second portion of circles. All right, we good? All right, I'm going to give you some work to do. Don't want to leave you empty-handed. Now look, this is where you really learn how to do this stuff. Watching me just kind of helps you a little bit. Hopefully it helps you a little bit. But this is where you really learn how to do this stuff. It's not even that many problems. There you go. 15 problems. 722, 723, 13 to 27. All right, have fun with that.